Okay, so today we're talking about logarithms and logarithm functions. Now, obviously, probably most of you haven't even heard of a logarithm in your life, which is fine. But going back to the first couple sections, we talked about exponential functions, right? We graphed like y equals 2 to the x, so on and so forth. Essentially what logarithms are, okay, is the inverse of an exponential function. So remember when we do the inverse, it's kind of like switching x and y. So like for an exponential function, we have b to the x equals y, so the inverse of that would be b to the y equals x. So again, when we're working with exponential, I'm going to kind of explain a little bit more here in a minute. But if log base b of x equals y, then we know b to the y equals x. Alright, so again, what does this mean? Log with a b, x is read as log base b of x. Alright, now, why do we use it? Well, again, we're not going to do anything that looks like this today, but down the road we will. Because, you know, we did some of this solving where it's like 5 to the power equals 10, solve for x. Well, essentially we needed to get this into base 5. Is there any way we can get 10 into a base of 5 to a power? There's not. Alright, so that's where these logarithms are going to come in. You know, we need to get this x down to the bottom so we can solve this out. Again, up to this point we don't know how. Okay, so in order to do that, that's where these logs are going to come in. But again, that's down the road, but that's kind of the why we use it. So again, to start out, they're going to start out really simple. There's to say, given the logarithm, write it as an exponential function. So how would we write this as an exponential function? Again, we're just using this pattern up here.
4 squared equals 16.
4 squared equals 16. Easy enough, right? Okay. Next one.
3 to the 4th power equals 81.
3 to the 4th power equals 81. Okay, so like I said, essentially what we're doing is we're drawing this to the power equals x, right? And that's essentially the pattern. So 4 squared equals 16. 3 to the 4th equals 81. So then when we come over here, now we're going to do the opposite. So write this exponential function as the logarithm. So we're going to say log base what? 5 of 25 equals 2. And again, we go backwards, 5 squared equals 25. Alright. Next one a little bit trickier because they throw a fraction in there. But again, log base what? 729 of 9 equals 1/3. Again, 729 to the 1/3 power equals 9. Okay. So again, really straightforward. Frankly, not. Alright, hopefully this isn't super hard, it's just different because we haven't done it before. Alright. The next thing they're going to do, they're going to ask you to kind of solve it. Now what I mean by solve is just like simplify. So they're going to give you like, I'll give you a really simple one first. Log base 3 of 9. What does this equal? Well, we're looking for what it equals, right? So we just set it equal to x. Now, how am I going to rewrite this as an exponential function?
3 to the x equals 9.
3 to the x equals 9, so what does x equal?
2.
So log base 3 of 9 equals 2. log base 1/2 of 128. A little bit trickier. But again, we just set this equal to x. So again, if I rewrite this, how would I rewrite this?
1/2
1/2
x
to the x power equals,
128.
okay? Then it's going back, now we're doing exactly what we've done in the past. Okay, it's just that first little step of rewriting it. Now the big thing, we need to get this into the same base. Okay, so 1/2 and 128 can both have a common base of what? 2. Okay, 1/2 is like 2 to the -1, right? And 128 is 2 to what power? I think the 7.
Yeah.
Okay, so it's like -1x or -x equals 7. So I know x equals -7. So this is like log 1/2 of 128 equals -7. So again, if you type in your calculator, 1/2 to the -7th power, we're gonna get 128. Alright, questions there? Log base 100 of 1. So one more at you. So again, rewrite this as what? 100 to the x equals 1. Anybody know what it is? Any number of what power gives you 1?
0?
0. X equals 0. So it's like log base 100 of 1 equals 0. Okay. Get rid of that marker. Alright, so questions on this. Alright, this is the base fundamental part of this. Now, one other thing that's part of your assignment that I'm gonna kind of take out, for the most part, what we're gonna do one anyways, is graphing. Okay, so they're gonna have us graph like f of x equals log base 3 of x. Okay. Well, again, if I write this, again, f of x is basically the same as what? Y. So I could write this y equals log base 3 of x. So now, how would I write that as an exponential? Three to the y equals x. Okay. Well, again, when I make a table, typically I plug in values for what first? I plug in values for x, right? Okay, to get my y out. Well, in this case, again, this is like the inverse of y equals 3 to the x power, right? Okay, so instead of plugging values in for x, we can plug in values for y, because I don't know how to plug in values for x and get y. Okay, so 3 to the -2 power is what? -9. Because remember, anytime we have a negative exponent, we gotta flip it to the bottom, so it's like 1/3 squared. 3 to the negative 1 is
One-third.
1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Okay, so I go through and I plot this 1/9. Okay, so I'm really close. -2. 1/3. -1. 1 0. 3 1. And 9 2. So again, this looks similar to an exponential function, right? But again, it's the inverse, so it's flipped over this y equals x line. Okay, like if we were to do y equals 3 to the x, right, it would look like that, so essentially this is just flipped over. So again, essentially that's what logarithms are, again, just the inverse of an exponential function. Okay. So like I said, I'm not gonna make you graph a bunch of those today, just kinda wanted to give you the idea. So today's assignment is page 472. Through 37 on. Like I said, one problem where you gotta graph it, the rest of them are all what we did before.